We're going to be talking about Java interfaces and enumerators today. There we go, slapped together by me. So we're just going to hop right into it. I got rid of the pointless overview page. I think we kind of understand what we're doing. So a Java enumerator is essentially a special data type that contains a set of constants for you to reference as a source of truth, essentially. So this bottom bullet point here, they can be conceptualized as storing a state or like a constant state within the class. So enums or enumerators is how I'm going to probably keep calling them. It's what they're short for. Enumerators are not intended to implement functionality themselves, but represent what action should be taken upon the enum value. So like the enumerator itself is going to look like this with all capital letters in Java. In Java, the enumerator values have to be capital letters with no strings or anything like that, just all capital. And then down here you can see how we can utilize this functionality by running some sort of function or method off of the class and checking if you just imagine this says day, is the day currently Friday? And so if it was, then we could print this line out to the console. And so you can use enumerators essentially to be like, not the way we're used to storing state, but essentially like the behavior of your application. So I have a working example now. Caveat, it's C#, but they're very, very similar. And I think this is a good example of why and how you would use this. And so there's a lot of code. But what's going on is I initialize my enumerator up here. So I was building a game. I have my alive, dying, and transcending. The guy wanted us to call it transcending. That just means you've completed the level, right? So right here you can say, if my state does not equal alive, then return. So it's going to go out to a different function. Otherwise, this is a built-in method. It's going to say here, if I hit a friendly object, don't do anything. But if I finish, then success condition is met. So if we look over here, I change my state to transcending. So that way the game knows that I'm in a different enum state. So now I have a loop. It's called an update function, where as you're running the game, it's constantly checking your enumerator every single time. And so once I have success condition met, once the player actually hits the finishing platform, then we change our enumerator, and then all of this operation changes, and we move on to the next level. Same thing if you hit a death condition, like a barrier, I run this condition. So now I'm changing the state to dying. And this influences my game behavior, right? So even though it's only 3 words, alive, dying, and transcending, you can see how much of an impact it can have on my game, because it's determining what my actual game state is at that current point in time. So we're not going to be storing like enormous objects inside of our enumerators, but they're essentially like ways to show what status your application is currently in. Does that make sense to everybody? I'll bring it back to the Java. So I think, yeah, see when I initialize here, these are lowercase, that's C#. You don't want to do that. Java enums look like this. They're capital letters. That's pretty much the only difference. I guess I didn't need to declare it as public, but whatever. So there you go. Any questions on enumerators, enums? Cool. So Java interfaces. Implementing an interface allows a class to become more formal about the behavior it promises to provide. Interfaces form a contract between the class and the outside world, and this contract is enforced at build time by the compiler. If your class claims to implement an interface, all methods defined by that interface must appear in the class before it will successfully compile. It says source code, but the class. So interfaces in their most common form, accidentally skipped ahead. Interfaces in its most common form are just a group of related methods with empty bodies. They can only be public or package scope, however. You cannot declare an interface as private or protected. If you don't declare whether it's public or package scoped, it's going to default to package scope. So interfaces are more akin to a blueprint where a class can import however many interfaces to add functionality to the class itself. And this is useful because Java classes only can inherit from one class, but they can use multiple interfaces. So here you can see we have an example of an interface on the left, but when it hits the compiler, you can see it adds all of these modifiers on the end. And so this is what I was talking about when I was like, what does that mean? So right here, final and abstract. We're going to talk about that. Any questions on this overview so far? Cool. So what is final and abstract? An abstract method is a method that is declared without an implementation. So you will do this a lot with interfaces. Instead of opening up the curly braces, you simply say exactly what it's going to return, nothing, and then we're inserting our variables here, but there's no curly braces. So this is a abstract method that you would put in an interface. And for all intents and purposes, the final keyword means it's a constant. It's kind of like static, where it's like initialized at runtime and never changes. So when you see the final keyword in this interface, this is a constant value. So if you had an interface where you're like, I want to make sure I have this constant of, pi, I don't know, then you could have that hard set with the final variable to the value of pi, and then anybody that brings in your interface has access to that value. So let me go back. So the Java compiler does auto-convert interface types to final, static, and abstract. We don't see this happening when we declare it, but it happens after the compiler runs through it, rather. This means we cannot create an instance of an interface because we have to implement, we must have a class to implement the functionality. You cannot create an instance of an interface. It's literally meant to be like a blueprint. It's like, this is what I am intended to do, these are all my methods, these are what they return, and now when you implement them with your class, you can do whatever you want with them. So here's a little bit more examples. In the upper right, you can see that one class can implement multiple interfaces, and one interface can extend multiple interfaces. However, one class can only inherit from one class. So over here, we kind of just have a bunch of code going on. Here's an example of an interface that simply has that, I keep forgetting the name, abstract method. But then in here, when we're implementing it, you can see that he's calling the same word with void, right? But he's making it public and it just prints out hello. But this is a class. So then down here in his main class, right, method, in his main method, he instantiates a new instance of this class. So this is an instance of the class, not the interface. So we're not creating an instance of the interface. But when we create this instance of this class, we're able to call that interface's function, and then we get hello as an output. Here's default. Default, I will show you an example of that. It's a new thing introduced in Java 8. It pretty much allows you to declare non-abstract methods inside of an interface. This was a feature that they added in Java 8 because they wanted to add more functionality, but the way that their interfaces work is they didn't have this default method. So if people wanted to add functionality to that method, it would essentially break it because you would be changing the way it was expected to work. So the Java developers created this default keyword where you can have however many methods inside of your interface as you want, but the default will be the fallback if no other methods are called within that interface. So that's why right here we have this default. This is going to be allowed to be declared, and we can actually just call it like this. Well, there's no class here. If there was a class below this that was implementing drawable, we could simply just call message and it would do everything for us. Whereas up here, this is an abstract method where we have to describe the behavior. And then on the right, we have an interface extending an interface. So they both have two separate functions. However, when we implement showable, which is already extending printable, you see that we have access to both of those methods. So printable is at the top. So then we declare a new one called showable, which is extending it. So now technically it has access to both of these. But the cool thing is since we're just implementing showcase, we already have access to both of these since it's extending printable. And so finally we're able to use those methods down here. And again, these are abstracts, and we have to declare their functionality inside of the class. And then finally we get to create, again, this is a class. We're creating an instance of the class, not the interface, and then we can call those methods off of the instance of that class. Any questions? I have a working example too. So defender methods are also default methods. It's like I just said earlier. It was newly introduced into Java 8 and allowed developers to add more functionality to existing interfaces in addition to being able to declare multiple non-abstract methods that allow the Java source interfaces to stay the same, but now with the option to add additional functionality using override or extending an interface, for example. So I was messing around. Same REPL link. I already had it open. So here, this is the same file I've been working with. I just commented out all that, like when I was doing like the array list stuff. So this is the same file. And you can see up here, I declare an interface. So this would be a final. This right here, and as a matter of fact, as an example, I showed this commented out. This works exactly the same, whether this says final or not, because the compiler is going to put that in there anyway. So right here I have a constant that just says TES, short for test. I was just throwing this together to see how it all works. Here we have an abstract method. So this is one that I didn't actually declare any functionality on. That's why it's an abstract method. And now here you can see I declared two default, so defender methods. And these I can actually declare within the actual instance. So now I have a helper class that's going to implement this functionality. And now I need to give tester, which is an abstract method, its functionality, and I'm calling it on this constant because I have access to it because I'm implementing it. So this class has access to everything going on in test because it's implementing test. So down here, I create a new instance of it, just like we saw in the examples. I create a new helper class, and down here, I called it toShow, and I just run those three methods. So even though this one initially is an abstract method, since I declared its functionality in here, we still get 0 over here, where I declared right there, right? Similarly, like I said, if I put final, which means it's a constant, it's still going to work. The compiler's just going to be like, oh, you did my job for me, thank you. So there you go. So a lot of these things like abstract, I think I could put like abstract in front of here. You could add these words if you want, but at the end of the day, the compiler does it for you automatically. So why bother? But as long as you know that the compiler is actually adding those key words and that's why these interfaces are able to work, then you're set. So again, just to recap, I declared an interface. I declared a bunch of features in this interface. I created a helper class to implement this, and then I created a new instance of it, and I called all of those functions off of that instance. Any questions?
So if you don't like do the helper class for the tester, will it default to the tester 2 or the tester 3?
Because I have this abstract method here, this would need to be declared. I think I was running into that error before. So if I just wanted to implement test straight into main, I would need to make sure that I actually declared this in here. I just threw this together really quick as I was like researching more and more about, I thought interfaces was going to be simple, like I said. So I just wanted to give you guys an example of how you can do this. I was running into some sort of error, but I think all you have to do is just declare this method inside wherever you implement it. But as an example, you can also use a helper class as well. So if you want to isolate the different, I keep forgetting all these words. If you want to isolate the interface's functionality into different parts, you can do that with helper classes. My brain. All right, so yeah, that's defender methods. They're also called default methods. There's my REPL in case you wanted to go and check that out yourself, mess around with it. And so these are my references. A lot of Java docs, some YouTube videos just to kind of give me an overview of what they are, and I believe that's it. Yeah. Are there any questions on that? Is that everybody feeling comfortable about like what an enumerator?
Did you look at the override keyword? Is that for default?
Override would be if you wanted to use an interface, so like list is an interface. Java has built-in interfaces. See? So list at its core is an interface, so you would use the override feature if you wanted to redefine something like last index of. If you wanted to change the behavior of last index of, then you would put at override above it, and then like redeclare the functionality of that essentially. So interfaces exist in Java. You could see super interfaces. I'm guessing that's probably known sub-interfaces. So yeah, it's like a nested structure you can see. So we have the parent interface, and then we have these sub-interfaces. And we can go back to list. So interface collection helps create list, its functionality. Does that make sense? Does that help? Yeah, that's what you would use override for. If you're declaring your own interface, then you probably don't need to worry about it. But yeah, if you would want to override an already existing method, and that's why the defender methods are important, because on all of these methods, there's a defender. On all of these interface methods, there's a defender method now with Java 8, which means that you can override it, but if something goes wrong, like you don't break the functionality of it entirely. Whereas before you would like literally have to break it in order to get it, which obviously would not work. Yeah? Yeah. So, yes, it would look like this. There's 2, 2, 4, 5, 6, and then for implementing that, come in, do copy this. Again, this is just like a really quick example. So this is TS2 now. This is tester 4. Otherwise, everything else is declared with our defender methods, and then we don't need to worry about this because it's a final, it's a constant. But then down here, I need to call to show on all the other methods. So let's just copy a couple of these. Tester 4. Tester, yeah, 5, copy, paste, 6. That should do it. Because now this class is implementing both of those interfaces. So unless I'm missing something, oh, there might be name, oh, okay. There is name clashing between interfaces. That's actually, I'm glad you brought that up. So if I name these things exactly the same thing, it would error out because there would be name clash inside of this class where I'm trying to call everything. So like if I had 2 different interfaces, I couldn't have like tester again, for example. They need to explicitly be all unique names. Theoretically, this should run, but with my luck, it won't. Oh. Man, that feels great. Awesome. Yeah, there you go. So that's what implementing 2 interfaces would look like, just that right there. And again, classes can implement multiple interfaces, but they can only extend one class. So here, since it's in the same file, all I need to do is just create a new instance of it. But what was I going to say? I totally brain farted there. Yeah. You can, anyway, I'm sorry, brain fart. Any other questions? Sorry. Any other questions? Yeah.
I'm like forgetting what extends actually does.
So yeah, extends means that it takes the base functionality. So like if you say class rectangle extends square, it's going to have all the functionality of a square, but then you're adding additional functionality to rectangle because it's extending the functionality of a square. So when you type in blah 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 extends, that's what that's where I was getting at. That's why I don't need to type this in, because technically it's not extending helper. I'm creating an instance of this helper class. I don't need to extend it, I'm just creating an instance of it. But if I wanted to, like, for instance, have helper extend main, I'm already implementing, but you could do class helper extends main, and then you could do all this functionality and still have access to the variables inside of main. Probably with some caveats. I don't know if like protected allows you to do that, but I'm sure there's documentation on the specifics of that. So yeah, that's what extending would be like. You have access to everything on the right, and you're declaring a new class, and you're like upgrading the class on the right. Any other questions, guys? Yeah, it's kind of like a modifier that you declare over the method. So I believe if you had like multiple, you would need to do override multiple times. So like if you want that to override, you need to do that. If you want this to override. Now, typically you do this over like method declarations. So I would probably do this not there, but like on my array list generator. You know, if I was overriding an already implemented method, interface method, then I could come in here and I can go override, and then this could be like get, right? So I don't want to use their get, I want to use my own get. So I'm going to override their get, and I'm going to create my own. Whereas if I didn't put override and I tried to do this, it would be like, hey dummy, we already have that, and you can't do that. There's like name clashing again. Any other questions, guys? John will talk about lambdas and streams tomorrow. I think lambdas somehow factor into interfaces, but I didn't see too much on that, so I didn't dive too far into that. Clarence?
Okay, so what else? Honestly, apart from this, using is to prepare without using code. If that's the case, can we use those methods for other states?
I mean, it depends on what and how you consider state. I do know that interfaces always need an abstract method. It's like a weird rule. I ran into that error trying to write this. It does need at least one abstract method, but as long as it has at least one abstract method, then you can declare a bunch of default defender methods. In which case, if we did have an enumerator, I don't know if I need to call the enumerator. Let's see. Is it enum fun times equals totally cool. And so here, let's do fun times dot totally. This might error out. Yeah. The enumerator is without the assignment operator, right? Cannot find symbol. Let me see how they did it real quick. Public. Oh, do I need to make it capital? That might be what it is. I'll make it public. It's not liking it. I think if I just came down here, if I just did it here, system. Oh, I think you would need to set it to actually. Let's do that. Oh, I still have my thing up there. Well, should probably stop the recording until I figure this out.